Hello and welcome once again to Bubbling. And in this video, we will be carrying out experiments to test the accuracy and reliability and consistency of ChatGPT automating this network. And to get that done, we'll be conducting 100 experiments. 100 experiments, and we want to see if ChatGPT will be able to continuously generate playbooks that will successfully automate this network. So to start with, we will log into router 1's console to check what routing protocol we have configured. None is configured, and we do not, and the interfaces that are currently configured are necessary for our routers to have connectivity to the controller. So we have just two interfaces configured, no loopback interface is configured. So we'll do the same for router 2 as well. Show routing protocol shows that no routing protocol is configured, and when we check the interface configuration, we see that just the G00 and G02 interfaces are configured. So for router 3, when we check show IP protocol as well, no routing protocol is configured, and show IP interface brief shows us that just the G00 and G01 interfaces are currently configured for connection to the controller. And finally, for router 4, we will also see that no routing protocol is currently configured, and the interface that is configured is just the G00 interface for access to the controller, for connection to our access to the controller. So with that, we will move into bubbling and begin automating of the network. So the first thing we're going to do is say no to this question. For the very first experiment, we will manually input the configurations we have on this topology, and from experiment 2 to experiment 100, rather than imputing the parameters, we will just load the this very configuration that will be saved as a result of the inputs we are going to do now. So now we'll say no and manually carry out the configuration. So first, how many routers do we want to configure? We have 4 routers on the topology. For router 1, we want to configure 2 interfaces, which are the 2 loopback interfaces. So we say 2 here. We have just one routing protocol, which is OSPF, which has an area ID of 1 and a process ID of 1. So we will be advertising all 4 networks. The first being 172. This is a typo. This is supposed to be 172, as we can see here. Okay, so 172.168.1.0/27. Okay, and the next will be for G01 interface 192.168.2.0/30. Next, we will advertise the loopback interfaces 192.168.10.1/24 and .20.1/24. Loopback 0 will be 10.1 and loopback 1 will be 20.1. So we're done with router 1 configuration. For router 2, how many interfaces? The 2 loopback interfaces as well. Now we have 2 routing protocols to be configured. On G00 we have OSPF, and on G02 we have EIGRP. So first we will configure the OSPF, which has an area ID of 1 and a process ID of 1. Number of networks to advertise: we will advertise the G00 interface and the loopback 0 interface, so that's 2. The first is 192.168.2.0/30, and loopback 1 is 192.168 192.168.30.1/24. We are intentionally imputing the host IP to hasten configuration of the interface. So for the second routing protocol, we have EIGRP with an ES number of 10. Number of networks to advertise will be 2, that is G02 interface and the loopback1 interface. So 192.168.4.0/30 and then 192.168.40.1/24. So loopback 0 interface will have 30.1 as IP address, and loopback 1 will have 40.1 as IP address. Done with router 2, we move into router 3, which also has 2 loopback interfaces to be configured, 2 routing protocols, that's EIGRP on G00 and G001, we have OSPF. So first we configure the EIGRP with an AS number of 10 as seen on the topology. Number of networks to advertise will be 2 as well. That's the G00 and loopback 0 interface. So 192.168.4.0/30. Alright, and then this should be 24.1, and then we have for loopback 0 is 50.1. Okay, so second protocol will be OSPF with an area ID of 100, process ID of 1. Number of networks to advertise will be 2 as well, that's G01 and loopback 1 interface. So we have 192.168.6.0/30. Alright, and then we have 192.168.24 here, 1, and then this will be 60 for loopback 1. So loopback 0, we have an IP address of 50.1. On loopback 1, we'll have an IP address of 60.1. Finally, we move into router 4, which has 2 interfaces to be configured as well. One routing protocol, which is OSPF with an area ID of 100, process ID of 1, and number of networks we're advertising all 3 networks on it. First being 192.168.6.0/30, then 192.168.70.1/24, and finally 80.1/24. So loopback 0 is 70.1 and loopback 1 would be 80.1. So with that, we're done with configuring all the routers. We move to the first checkpoint to confirm that our configurations are correct. We'll click on yes, and then a prompt is generated with containing the parameters we just imputed for router 1, and then is sent down to ChatGPT to generate the playbook for router 1. And when we get the response for that, we will go through a second checkpoint to confirm that we are fine with the playbook that ChatGPT generated. And this is an experiment, so we will just run it and see if there will be a failure. If there's a failure, then that means that accuracy for the playbook is not okay, so there will be a loss in mark. But if it runs fine, then that means we can say that accuracy is fine because there is no error in the playbook being that was generated. So now the playbook has been generated, and we will just go into router 1 to confirm that we are there, and then execute the playbook and monitor the logs on router 1, as the playbook is being generated. So the expectation is that chat bubbling will log into the router 1, which has happened here. Then next configure the loopback interfaces and the OSPF interface as well. So that has been done, and playbook and bubbling has logged out of router 1 and has come back to generate the prompt for router 2 playbook to be generated. So while that is being generated, we will just verify the protocol here configuration, so we can see that the OSPF routing protocol has been configured with the desired networks to be advertised and the correct masks also implemented. So next we check for the interfaces, show IP interface brief. We can see that loopback 0 and loopback 1 have also been configured correctly, as we desire. So for router 1's configuration, we can say that this is 100% accuracy, because it generated our desired output. So for router 1, so the playbook for router 2 is generated, and we will log into the console of router 2 so that we can monitor the execution. Press Y for execution here, and then watch the playbook being generated. So the expectation is bubbling logs in. Okay, all right, so we can see that the configuration is completed, and the OSPF adjacency has been established between router 1 and router 2. So, and that's based on OSPF configuration here, and the loopback interface is also configured. So adjacency, OSPF adjacency has been established between these two routers. The expectation is that when we check show IP route, we are currently on router 2, so all these networks on router 1 should be discoverable through OSPF. So we should have about 3 networks being discovered through OSPF, as we can see here. Okay, 192.168.10.1, 192.168.20.1, and 192.172.168.1.0 are discoverable. So okay, so the playbook for router 3 has been generated as well. We will press Y here before then go into router 3 to check what is going on. All right, so Y, and then the expectation is bubbling logs in and then starts with configuration of the loopback interfaces and the loopback 1 interface as well. And next, EIGRP configured. We can see here that EIGRP adjacency has been established between R2 and R3, which is a good update. So that is completed, and the prompt for R3 is being generated. So while that is being generated, our expectation is that from R3 we should see all the networks on R1. So show IP route. Okay, so we can see that those have been what's it called, advertised as well through external EIGRP. So the first is 172.168. okay, over here on router 1. Then next we have 192.168.10.1, and we have the 20.1. Then for 30.0 as well, which is on router 2, we can see it here. And then the what's it called, EIGRP advertised network for router 2, which is loopback 1, is also seen here. So for router 4, the prompt for router 4 has been generated, and then we will go into router 4 to so that we can monitor the logs as well. Press Y here, enter. As you know, usual, we expect bubbling to log in first. After a successful login, configure loopback interfaces and then configure the OSPF next, and log out of the router. So we can see that OSPF adjacency has been established here as well, which is good news. So again, our expectation is that all the networks between R1, R2 and R3 should be discoverable by R4, in the routing protocol. So we'll check the routing protocol for R4 now, and we would see that all the routing, all the what's it called, networks can be are in R4's routing protocol. So we start from 10.1 here, then we have 20.0 as well. Here we have 30, sorry, this is 20, of course, same thing. Then we have 30.0, we have 40.0, we have 50.0, and then we have 60.0 here. So 60.0 is discovered through OSPF, because it's directly connected to it. So we have 10 here, 20, 30, 40, 50 and 60. So all networks can be reached by R4. So now that we have that, let's go back into R1, and the expectation is that on R1 all networks between R4, R3 and R2 should also be discoverable. So we do show IP routes, okay, and we would watch to see that we can see .30, .40, .50, .60, .70 and .80. So here we have the first network is 192.4, okay, which is this network here, 192.6, which is this network between R3 and R4. Then next we have 192.168.30.1, which was discovered through OSPF here, that is this. Then next we have 40.0, which is loopback 1 interface on R2. Then we have 50.0, which is loopback 1 on R3. Then 60.0, which is loopback 2 on R3. We have 70.0, which is loopback 1 on R4, and then finally we have 80.0 here, which is loopback 1 on R4. So the first experiment was 100% successful, and then we will go into the second experiment next. Thank you so much.